All right, this is the distance topic on Study Island. It's just about applying the Pythagorean theorem to a coordinate plane. So just remember what the Pythagorean theorem is. The Pythagorean theorem states that if you have a right triangle, that the two legs squared and added together is equal to the square of the longest side, the hypotenuse. In other words, a squared plus b squared equals c squared, where A and B are the short sides of the right triangle, and C is the long side of the right triangle. So remember that, because we're going to use that all throughout this topic, and that is the letter B right there. We're going to use that all throughout this particular topic. Now, here's number one. Vidal is applying painter's tape along the edge of the ceiling of a room to prepare for a project. The dimensions of the room in feet are shown in the graph, where 1 unit equals 1 foot. How many feet of painter's tape will Vidal need for this room? So this room is outlined here in red. If we want to know how much painter's tape we're going to need, we just figure out what the perimeter of the room is, because he's putting tape all along the edge of the ceiling. So for most of this, we can just count. All we have to do to count how much the perimeter is go along the room, and we can just go ahead and count the distance from this point to this point, one step at a time. Each unit is 1 foot. It's 10 units from there to there, so that's 10 feet. Now, you can count one at a time. You can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or you can say, hey, the x-coordinate here is -2. The x-coordinate here is +8. What's the difference on a number line from -2 to +8? And the distance is 10. So that distance is 10. Well, what about this distance right here? Again, that's just counting. This is at +5. That's at -3. The distance between those two values is +8. So you've got 8. So 10 and 8. And then finally, along this distance right here, you've got +8 to -8, which is 16. And again, if you really wanted to, you could just count one at a time. But going from +8 to -8 is 16, because this point is at -8, and this point is at +8 on the x-axis. So we've got 10, 8, and 16 so far. But you've got one more here, and this is going to be a little tricky. How do I find the distance from this point to this point? It's a slanted kind of line. I can't just count up and down or left and right. So what I have to do is I have to make a right triangle and use the Pythagorean theorem. This is what I'm going to do. Watch the green line here, this green line. I'm going to turn this slanted line into the hypotenuse. Label it C. Then I draw a line from here straight down and straight over. So let's look at this green triangle. I just made a right triangle. It's a right triangle. This distance is 8. This distance is 6, because we can count from here. 1, 2, 3, 4, 5, 6. So I now have a right triangle with legs 6 and 8 and hypotenuse C. So let's plug that into the Pythagorean theorem. 6 squared plus 8 squared equals C squared. 6 squared is 36, so 36 plus 8 squared is 64 equals C squared. And 36 plus 64 is 100. So 100 equals C squared. And then we take the square root of both of those sides. The square root of 100 is 10. And the square root of C squared is C. So C equals 10. So what is the perimeter of this whole thing? It's 10 plus 10 plus 8 plus 16. So 8 and 16 is 24, 34, 44 is the answer to this problem. And we just find that in our answer. Now, one thing that you're going to realize is that if you actually looked up something called the distance formula, it's going to look really complicated and confusing. I didn't use anything called the distance formula. I used the Pythagorean theorem, which is what the distance formula is. Check this out real quick. So this is the distance formula. Distance is equal to the square root of y2 minus y1 squared plus x2 minus x1 squared. Now, if that looks super confusing to you, don't worry, it's not. Let me break it down for you one little part at a time. Let's say you've got a coordinate plane here, and you could put 2 points on here anywhere you want. How about like right there, and I don't know, right around here, let's say. If I want to figure out how far apart those points are, that's the distance of a line that connects them. So the line that connects them is right there. Now, if I want to find the distance of that line, every single time that I want to do that on a coordinate plane, all I have to do is make a right triangle and use the Pythagorean theorem. Well, to make a right triangle, first I'm going to draw a vertical line, and I'm going to start that vertical line on one point, and I'm going to stop that vertical line when it becomes even with the other point. So what did I just do? I just drew a vertical line that's how far? Well, it's easy to see. 1, 2, 3. That's clearly 3. You can just count it. You don't have to do anything special. But if we think about it, what did I just do? I took the y coordinate for this point, which was, if I look at it, it's 4. And I took the y coordinate for this point, which is 1, and I found the distance between 4 and 1. What is 4 minus 1? And the answer is 3. See, this whole point, it's at the coordinates 1, 2, 3, 4, 5, 6, 4. So this point right here is at 6, 4. So there's the ordered pair, 6, 4. And what's this point at? It's at -1, -2, -3, -4, -5, and +1. So -5, +1 for this point. So the y coordinates, if I subtract them, I get 3. And that's how you find the distance between these 2 points vertically. You subtract the y coordinates. 4 minus 1 is 3. You get your answer. They're 3 apart. So if I called this my first set of coordinates, then I would refer to -5 as my first x coordinate, or x1, and my 1 as my first y coordinate, or y1. Then I've got my my second x as my second x coordinate, so x2. And then the 4 over here is my second y coordinate, so y2. So I took the second y coordinate, 4, and I subtract the first y coordinate, 1, and that turns into 4 minus 1, and I get 3. Well, if I want to find the horizontal distance between them, I draw a line from one coordinate, and I stop it when I'm even with the other point. I now have a right triangle because I have a vertical line and a horizontal line, so they're going to meet at a 90-degree angle. Now, how far apart are those? Well, from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's 11. Aha. Well, how far apart are 6 and -5? They're 11 apart. And again, that's a subtraction problem. If I do 6 minus -5, when you subtract a negative number, you add, don't you? So I get 6 plus 5, and 6 plus 5 is 11. So horizontally, they're 11 apart, and vertically, they're 3 apart. And I could tell just from the coordinates, because I just look at the difference between the y coordinates and the difference between the x coordinates, and I have my horizontal and vertical distance. Well, my horizontal and vertical distances are going to be the legs in my Pythagorean theorem, a squared plus b squared equals c squared. A and B are the horizontal and vertical distances. So horizontal is 11, vertical is 3. So I plug those in for A and B. It doesn't matter which one's which. I'll just go ahead and say that 3 is A. So I've got 3 squared plus 11 squared equals C squared. Well, if I want to solve for C, I've got C squared. So I'm going to have to take the square root of that. So if I take the square root of both sides, because anything I do to one side, I have to do the other. So the square root of c squared is what I get there. And the square root of c squared is c. Or, if you will, it's the distance between those two. So everywhere I put a c, if I just put d for distance, it's the exact same thing, isn't it? I just used a different letter, d for distance rather than c for hypotenuse. And I have the square root of 3 squared, which remember was 4 minus 1, and then we squared it, plus 11 squared, which remember was 6 minus -5, and we square that. So that's a little crammed, so I'll draw that out a little bit bigger. We had 4 minus 1, and we're going to square that, plus 6 minus -5, and we're going to square that, and that's equal to the distance between them, right? So 3 squared is 9, 11 squared is 121, 4 minus 1 is 3, right? So you get the square root of 9 plus 121 is equal to the distance, so the square root of 130, and whatever that turns out to be, that's your answer, right? Well, that's what we get for the distance formula. We go back to the distance formula. Take the 2 y coordinates and subtract them. Take the 2 x coordinates and subtract them. This gives you the vertical distance between the 2 points. So the vertical distance is y2 minus y1. x2 minus x1 gives you the horizontal distance. okay, the horizontal distance between the 2 points. And then if you square both of those and add them together, well, you're doing that because you're supposed to do a squared plus b squared, and that equals c squared. Well, if I take the square root of both sides, I get that c is equal to the square root of a squared plus b squared. And that's where the distance formula comes from. The square root of a squared plus b squared is the square root of the 2y coordinates subtracted and then squared, and the 2x coordinates subtracted and then squared. So that's where all that comes from. Now we can actually jump more into the problems here. Number 2, you got point A and point B. Find the distance between points A and B. So here we go. Go ahead and draw a vertical line and draw a horizontal line between them. Find their distances and use the Pythagorean theorem. You don't have to use that complicated distance formula if it confuses you. All you have to do is find the distance from A to B by drawing a vertical line and then a horizontal line and using the Pythagorean theorem. What was that distance right there? 2. What's this distance right here? 1, 2, 3, 4, 5, 6, 7. So 7. And then we're going to use this as D for distance or C for the hypotenuse, whatever you prefer. So here we go. The distance is equal to 2 squared plus 7 squared, but then I want the square root of that. So if I just put squared here, C squared equals A squared plus B squared, all right? And I'm using D for distance instead of C for hypotenuse. So A squared plus B squared equals C squared. That's the Pythagorean theorem. I'm using D for distance instead of C for hypotenuse. My A was 2, my B was 7, and again, those are interchangeable. So here we go. Let's go ahead and keep going. The distance squared is equal to 2 squared, which is 4, plus 7 squared, which is 49. So the distance squared equals 53. So I go ahead and take the square root of both sides, the square root of d squared and the square root of 53, and I get the distance equals the square root of 53, whatever that is. Oh, hey, that looks like one of my answers right there, the square root of 53. If I wanted to write an exact answer, that's the only thing I could write. I can't write exactly what the square root of 53 is because it's an irrational number. Look what happens when I type 53 into a calculator and hit the square root symbol. I get this decimal, and it's really, really long. And this did not say to round, did it? It said find the distance. So if you have to find an exact number and you have to take the square root of a number that's not a perfect square, then you're going to end up with an irrational number that you have to round. So oftentimes we just leave it as the square root of a non-perfect square, because that is an exact amount, even though it's not really usable as far as like putting in measurements or something like that you have to get at a store. It's still the exact amount, the square root of 53. Next one, from A to B. What do we got? How far is it? You can just count. You don't have to draw it, but I like to. So here we go. I'm going to draw a vertical line and a horizontal line goes between them from B to A. Try it again. And then from A to B. And there's my triangle. So there it is. 1, 2, 3. And then all the way from -6 to +5 is 11, isn't it? So here we go. This looks familiar. 3 squared plus 11 squared equals C squared. This time I'm using C for hypotenuse because A squared plus B squared equals C squared. 3 squared is 9 plus 11 squared is 121 equals C squared. I hope you know where this is going at this point because you just saw it a couple minutes ago. So you get the square root of 130 equals C. No big deal. Square root of 130. So there you go. Square root of 130. We'll just go ahead and grab that on there and bam, there it is. Find the distance between points A and B again. Here we go. Draw a vertical line and a horizontal line between them. Here we go. Vertical from A to B. Horizontal from A to B. Here's my straight line. So there's C. Here's A and B. What's the distance from A to B here? From +3 to -3 is 6, because 3 minus -3 is +6. And from -5 to +2 is 7. So 6 squared plus 7 squared equals C squared. 36 then. 6 times 6 is 36. Plus 7 squared is 49 equals C squared. 36 plus 49. 5. And take the square root of both sides. And you get the square root of 85. Square root of 85 equals C. Now, square root of 85 is right there. It's choice A. So we're moving right along. All right, number 5, drag the tiles to the correct boxes to complete the pairs. Not all tiles will be used. Using the graph above, match the segment names with their corresponding links. So we've got a bunch of links here and a bunch of segments. So we need to find these 4 segments, CD, BD, AC, and AB. So let's just go one at a time. C to D. How far is it from C to D? So go ahead and make your right triangle. What is the vertical distance and the horizontal distance between them? And then we have a squared plus b squared equals c squared. So here we go. What is the vertical distance between point D and point C? Draw that line. Here it is. It's a pretty thick line. Clean that up. And then over. And that makes your right triangle. So 1, 2, 3, 4, 5, 6. And 1, 2, 3. So we've got a squared plus b squared equals c squared. So 3 squared plus 6 squared equals 45. And that's c squared, right? So a squared plus b squared is c squared. So a squared plus b squared is 45, then 45 is c squared. Well, 45 is c squared. What is just c? The square root of 45, right? Take the square root of both sides. Now, if you wanted a rounded decimal answer, you'd do that. But these answers are not in rounded decimal form. They are in square root form. So we just took the square root of 45, right? That's it. You can just leave it as the square root of 45. So when we had this answer in here, it was already telling us what to choose from our list. Okay, it was a square root of 45 units, whatever that is. Now, why do they say the square root of 45? Because when you take the square root, you get an irrational number. This decimal actually goes on and on and on and on forever. It doesn't stop right here at the end. It actually goes on for all time. So the square root of 45 is exact. As soon as I take the square root of 45 and put it in the calculator, all I can do is write down a rounded answer. So instead of rounding it, sometimes we just leave it in its perfect format, the square root of 45. So that's what the answer for CD is. 6 squared plus 3 squared is 45. So the distance between D and C is the square root of 45. Let's do another one. The next one is from B to D. So let's go ahead and figure out where that is. From B to D, again, draw a vertical line. You don't even have to draw it. You could just count it. Like, what is the x and y coordinates of D? What are the x and y coordinates of B? And how far apart are they? The y coordinate of point D is 2. The y coordinate of point B is -6. So how far apart are they? They're 8 apart. That vertical distance between them is going to be 8. Okay? Then what's the horizontal distance between them? The horizontal distance. This point is -7. Doesn't say it, but it's in between -6 and -8. And this is +8. So how far is it from -7 to +8? That's going to be 15. So you have your A and your B as 8 and 15. So punch them into your calculator. 8 squared plus 15 squared equals 289. So there you go. You got your answer. It's the square root of 289. But that's not on here. Why? Because the 289 is a perfect square. Take the square root of that, you just get 17. So that's why it says 17 units rather than the square root of 289. If you could actually take the square root and not get an irrational number, then you should. The square root of 289 is just plain old 17. Next one, we want from A to C. So let's do from A to C. How far apart are A and C vertically? Well, A is at +6, C is at -4. Those are 10 apart. So the vertical distance from A to C is going to be 10. All right, what about the horizontal distance? The horizontal distance from A to C. C is at -4. A is at +5. How far apart are -4 and +5? They're 9. Again, we're just subtracting here. If I had 5 minus -4, that turns into 5 plus 4. And 5 plus 4 is 9. So you're just subtracting the y coordinates. When we subtract 6 minus -4, we get 10. And then 5 minus -4, we get 9. So subtract the x and y coordinates, you get your vertical and horizontal distances. So 10 and 9. So 10 and 9 are your A and B. Your hypotenuse is the distance between those 2 points. So we plug in 9 and 10 of the Pythagorean theorem, and we're good to go. So here we go. 9 squared plus 10 squared is 181. 9 squared is 81. 10 squared is 100. 9 squared plus 10 squared is 181. Take square root of that. Ooh, ugly irrational number. So we're probably just going to have the square root of 181 as our answer. And sure enough, there it is right there. Okay, last but not least, from A to B, how far apart are those? How far apart are A and B? Well, let's find the vertical distance between them and then the horizontal distance between them. And we'll plug in the Pythagorean theorem just like all the rest of these problems. So here we go. How far apart is A to B? Well, A is at positive 6. B is at negative 6. 6 minus negative 6 turns into 6 plus 6. That's 12. So the vertical distance between them, 12. Okay. The horizontal distance between them from positive 5 to positive 8 is 3. So there are your A and your B. Plug it into the Pythagorean theorem. 3 squared plus 12 squared. So you got 9 plus 144 is 153. So the square root of 153 is your answer. And there it is. Next up. For this item, any non-integer answer should be entered as a decimal rounded to the 100th place. So this time we're going to round if we get a square root of something that's not a perfect square. We're going to round to the 100th place. Please remember that. The grid below represents a map of Mira's city. Each unit square represents 1 mile. Point O represents the location of Mira's office. Point A represents the location of the airport. The shortest distance between Mira's office and the airport is approximately what? We're just going to go ahead and find the vertical and horizontal distances between point A and O. Well, this makes it real easy because point O is at 0, 0. So the horizontal distance is just how far it is over, and it's at 0.4. It tells you right there what the horizontal distance is. Similarly, this tells you what the vertical distance is, which is 5. So you've got 4 and 5. So the distance between them, we can plug into the Pythagorean theorem. 4 squared plus 5 squared equals the distance between them squared. So here we go. 4 squared plus 5 squared. So you got 16 plus 25 equals 41. So the distance between them is whatever the square root of 41 is. Square root of 41, 6.403. So rounded to the nearest hundredths is 6.40. So 6.4 is what we can put in there, 6.4. Next problem. Number 7, what is the perimeter of the quadrilateral below, if necessary, round to the nearest tenth? So we're going to round if we need to, but none of these answers are rounded, so it shouldn't be a problem. Let's go ahead and count. Again, we're just going to count the perimeter, going all the way around it here. Try and zoom in so you can see that a little bit better. Here we go. Some of these we could just count. What is this vertically? From 3 to negative 6. This distance right here, that's 9. So we got 9 there. The distance from here to here, from negative 3 to positive 5, that's 8. And the distance from here to here, from 3 to 0, that's 3. That is an 8 if you can't tell. So what we're left with is just our slanted part. So we're going to make a right triangle out of it. And there's our right triangle. So there's our hypotenuse. So what is the distance from 0, which is where that is, to negative 6? That's obviously 6. And from negative 3 to positive 5, that's 8 again. We just did that. That's 8. Those look like 8s, but they're 8s. So we have 6 squared plus 8 squared equals our distance squared. So here we go. 6 squared plus 8 squared. So 36 plus 64 equals 100. So the square root of 100 gives us our answer, and the square root of 100 is 10. So that is 10. So we just got to add all those together. 10 plus 9 plus 8 plus 3, and you'll have your answer. 30 it is. So which one of these says 30? Zoom back out a bit. There it is, 30 units. Find the distance between points A and B. Here we go. Point A right here. Point B right there. What's the vertical distance? From negative 1 to positive 2 is 3. What's the horizontal distance? From negative 4 to positive 1 is 5. So we've got a 3 and a 5. And that gives our 2 legs to our right triangle. Again, 3 and 5. Pardon the sloppy writing there. So 3 and 5. So we've got 3 squared plus 5 squared. So 3 squared is 9, 5 squared is 25, 9 plus 25 is 34. Square root of 34 is our answer, and there it is. Choice B. Number 9, what is the length of the diagonal from vertex J to vertex L in the quadrilateral below? So from J to L, what's the distance there? All right, find the distance between them vertically, the distance horizontally, make your right triangle. So here's J, there's L. What's the distance here? From positive 3 to negative 2 is 5. So 1, 2, 3, 4, 5, easy to count. Distance here from negative 3 to positive 3, that's 6. And again, 1, 2, 3, 4, 5, 6. And that will give us the two legs to our right triangle. So 5 squared plus 6 squared equals our distance squared. Here we go. 5 squared plus 6 squared equals 61. So we get the square root of 61. Whatever the square root of 61 is our answer. There it is, square root of 61. Last but not least, what is the length of the shortest side of a triangle that has vertices at negative 3, negative 2, 1, 6, and 5, 3? So what is the length of the shortest side of a triangle that has those vertices? If you have a triangle with these vertices, then you have 3 sides. So we can find the lengths of all 3 sides pretty easily by simply using our Pythagorean theorem. What is the vertical distance between the first 2 points? Well, vertically, this point is at 6, and this point's at negative 2. So how far apart are these 2 points vertically? They're 8 apart. So if we're using the Pythagorean theorem, the vertical distance between those 2 points is 8. So we're going to start with that. We're going to start with 8. That's our A, if you will. We're going to do A squared plus B squared equals C squared. The vertical distance is A, the horizontal distance is B, or vice versa. You can switch those around. But they're 8 apart because I just did 6 minus negative 2 is positive 8. Okay? So 8 squared plus, all right, how far apart are 1 and negative 3? They're 4 apart. 1 minus negative 3 is positive 4. Okay? So 4. So we've got 8 squared plus 4 squared. That's going to be the first part, 8 squared plus 4 squared. 8 squared plus 4 squared equals 80. And if you want the distance between those 2 points, take the square root of that. You get the square root of 8.944. But all of these are in whole number or square root units. So we're looking at the square root of 80 for the distance between those 2 points. All right, let's try another set of 2 points. That was remember the first 2 points we just used in pink there. Let's do the next one. Let's do the first and the last point. Let's do that one in blue though. First and the last point. From 3, negative 2 to 5, 3. How far apart are they vertically? From 3 to negative 2 is 5. So you got 5 squared. Okay, so 3 minus negative 2 is 5. And then from 5 to negative 3, from 5 to negative 3 is 8. So 5 squared plus 8 squared. If you can't already tell that this is going to be more than the one we just did, which was 8 squared plus 4 squared, well, then you got to be paying a little bit more attention. We're looking for the shortest side, right? The shortest side. This was 8 squared plus 4 squared. This is 5 squared plus 8 squared. They both have an 8 squared, but then this one's 4 squared and this one's 5 squared. So clearly this one's going to be longer. So do we even really need to keep going? No, we don't need to keep going with this one. It's going to be a longer one. That said, if you wanted to figure out what it is, remember the distance between those first 2 points was the square root of 80. What about 5 squared plus 8 squared? 5 squared plus 8 squared equals 89. So the square root of 89 would be the distance between the first and last point. So let's do the last one now. Let's do the distance between 1, 6 and 5, 3. What's the vertical distance between those? From 6 to 3 is 3. So you got 3 squared. And the distance between 5 and 1 is 4. So 3 squared plus 4 squared. This is going to be the shortest one. Okay. So 3 squared is 9. 4 squared is 16. You got 3 squared is 9 plus 4 squared, 16. Add those together, you get 25. So the distance between them is the square root of 25, which is right there, 5 units, and we're done. Okay. So that's it. Good luck on this. As always, make sure you go through the lesson. We got lots of examples here for you. They're good. They're easy for you to read. Work hard. Good luck.